Danielle Kennedy, research civil engineer with the Coal Regions Research Laboratory, otherwise known as CRREL, and we're going to be talking about concrete innovations, Arctic and cold weather construction. Good morning, Danielle.
Good morning. Thank you so much for having me.
Well, thank you so much for being on the show. We're going to talk about a lot of interesting things, but one very interesting thing is I want you to tell me about yourself and your background.
Sure. So I have been with the ERDC at the Cold Regions Research and Engineering Lab, CRREL, for about 6.5 years now. I grew up in Florida and got my bachelor's and master's in civil engineering from the University of Florida. Go Gators. And during my time in undergrad, I was really involved in the American Society of Civil Engineers, ASCE, and I'm still heavily involved, but back then I competed in concrete canoe, which is an engineering competition where the students design, build, and race canoes made entirely of concrete.
Yeah, I was going to kind of investigate that. What?
Yeah, it's pretty cool. It's one of the student design competitions. So there's another one where you design a bridge out of steel that's like a scale size of a normal bridge. But this is kind of the other one. And so during my senior year, I was the captain of the team, and my love for concrete kind of started and bloomed from there. And so my team actually placed first in the nation that year with our canoe. It was called For Everglades, and it was inspired by conservation and education of the Everglades, since, we were in Florida,
right,
and we love nature and, the Everglades. And UF had never gotten first place at nationals before, so this was a really big deal. And that is where I got pretty interested in concrete, because all the teams are doing different things and using different materials. And so from there, I decided after I graduated, I wanted to stay at UF a little bit longer, and I enrolled in a thesis master's program where I was specializing in concrete materials. So I stayed on for a little bit and provided some mentorship to the concrete canoe team as well, and got to work a little bit more in concrete materials and do some lab research there, which was really fun. And
so you went from Florida to the opposite of Florida, How big of an adjustment was that?
It was quite an adjustment. I actually interviewed for the job in the summertime. And so I flew up to New Hampshire. It was gorgeous. July is just the best time in New Hampshire, and it was so pretty. And I was like, okay, this is great. I'm doing it. And then actually didn't start working and move up until November. And it snowed the day I moved in. And I don't think it stopped snowing for 4 months. So it was an adjustment, definitely.
Yeah, I was up there in December. It was 10. So there.
It's pretty cold.
Right. So what is your role at ERDC?
I am a research civil engineer. So I lead and support research projects related to concrete materials for the ERDC. And then I kind of wear two hats, because I'm also a program manager for a program called Rapid Entry and Sustainment for the Arctic, where we've got a lot of different projects, and it's in partnership with CRREL and also another ERDC lab, the Geotechnical and Structures Lab, and an academic partner, Rowan University, which is in New Jersey.
Okay, a lot of partners. ERDC is all about partnerships.
It is.
So we know that cold weather can cause problems in different ways, but can you tell us a little more about how it affects the process of placing concrete, and are there any unique challenges?
So basically, if fresh concrete doesn't meet a minimum amount of strength before it freezes, it will just stop gaining strength completely and have poor durability. So to combat this, the standard method is to heat that fresh concrete if your ambient temperatures are going to be below 40 degrees Fahrenheit. So you can do this with a heated blanket, you erect a tent, you have a diesel heater, but that can be really expensive and add a lot of cost to your project for the material, the labor to set it up, and it can add a lot of CO2 emissions to the environment as well. So I know Vicksburg isn't very cold, but you may have seen some tents around when there's new construction in the winter, and it's really common up north, and sometimes it's the only way that people can complete the construction work.
So since cold temperatures can wreak havoc on fresh concrete, could you explain how internal freezing impacts concrete strength development?
Yeah, so if concrete freezes before it has cured or gained enough strength, it will just stop gaining strength. And so we want to prevent any internal freezing before the concrete has developed enough strength. And this can take a day or even a week, depending on how cold it is outside and how big your placement is.
So, I understand the standard cold weather protection measures can be quite difficult and expensive, but CRREL has done something to combat that issue. Can you tell us about the additive regulated concrete for thermally extreme conditions, Arctic, and why is so helpful and innovative?
Sure, yes. So, yeah, we're the military, so we love those acronyms.
Oh, every single day.
Exactly. And so the standard method for placing concrete in cold temperatures, like I said, is you set up a heater and you have a tent, and that can add a lot of cost and effort, like you said. And so what we have done at CRREL is we have developed ARCTEC, additive regulated concrete for thermally extreme conditions. And ARCTEC is a guidance tool which takes into account ambient temperatures, mixture designs, locations, size of your concrete placement, and it provides recommendations on additive dosage needed to safely place that concrete without the need of a heated enclosure. And so
go ahead.
The ARCTEC tool provides a range of additive required for the project, and the end user can choose based on project costs and timelines how much additive they want to include in their concrete mix. And then we've also got safety measures on both ends to make sure there isn't too little additive or too much additive.
Well, I read in an article that the heated enclosures slow down construction. How does ARCTEC address that challenge, though?
Yeah, having a team set up and monitor a heated tent adds a large amount of labor and material requirement to the construction projects. So these tents are typically erected before the construction, and then they'll stay up during construction and for a few days afterwards, depending on how large the placement is. So that can add a lot of setup and monitoring time, in addition to the gallons of heated fuel that you're using to heat that area. Mm-hmm. So it can add up a lot for a really large concrete placement. And in 20 to 40 degree environments, ARCTEC completely eliminates the need for these heated enclosures. So not requiring a full heated tent enclosure and being able to simply incorporate an additive into the concrete mixture makes winter concreting so much simpler. And it allows users to extend their winter construction season and speed up their construction schedule at a much lower cost.
That sounds wonderful. Time is just precious too, so that's so helpful. So let's talk specifics. What are the key additives used in ARCTEC, and how do they protect concrete from freezing during winter construction?
Well, these additives that we're using, these are typical off-the-shelf concrete non-chloride accelerators. So we are not reinventing the wheel here. These are products that are already used in concrete industry and that users are familiar with. Concrete curing has an exothermic reaction, meaning it gives off heat as soon as the water and cement touch in the mixing process. Mm-hmm. And these additives speed up the rate of hydration, which speeds up the rate that concrete is giving off heat. And it allows the concrete to meet those required strengths at an earlier age.
So geometry, mixture, proportions, ambient temperature, these all play a role in successful concrete placement. How does ARCTEC's guidance factor in these variables with civil and military applications?
Yeah, so our current setup at CRREL includes an in-house adiabatic temperature rise chamber, or an ATR chamber. We love acronyms.
Right.
And this allows us to mix comparable mixtures for civil or military projects and collect temperature data, which we then simulate at different temperatures and conditions to help build data into the ARCTEC tool. For civil applications specifically, the temperatures typically aren't too much below 20 degrees outside when your DOTs or the Army Corps is doing projects. They're just not able to, place concrete much colder than that. But the placements can be really large. So think about maybe a new construction for a lock or a dam. These are, massive multi-year construction projects. And so if we can extend the window of construction, even from 40 degrees down to 20 degrees Fahrenheit, allowing them to place concrete at that temperature, that can extend the construction season through an entire winter in some areas of the country, except for, really extreme cold days. But if we're able to say, if you incorporate this additive at this amount, you can place concrete basically year round in a lot of areas of the country, which is really helpful.
What they call that is a game changer.
Exactly. And, we're working with a group in Pittsburgh, and when we first started working with them, we said, okay, we can get it below 40. We weren't really sure how cold we could get it. And after doing all of our modeling and all of our work with them, we realized if we can just lower this range down to 20 with additives, that's the entire Pittsburgh area winter season. They're going to have a couple days below that, but not for an extended amount of time. And it really helps them to be able to place concrete as they need to keep their projects going and stay on schedule.
Right.
But then for the military applications, which is a little bit different than civil applications, we want to go colder. How cold can we go using just basic materials that would be easy to get in an expeditionary environment to help our military place concrete in these Arctic regions? So we've been working with some pretty cold conditions, and we placed some concrete pads up at our test site in Fairbanks, Alaska a couple of years ago, and learned a lot from that experience. And from there, we're confident that we can recommend ARCTEC at even colder temperatures. And our goal in the near future is to be able to provide recommendations for ARCTEC at the military's extreme cold range, which is down to negative 60 degrees Fahrenheit, which I can't even imagine, but we're trying.
Well, an earlier show of the season, we have Amanda Barker. So she's talking about permafrost. So, I think people now understand more about that, so they can understand more about these temperatures that you're referring to. So not Definitely. That they can more imagine, not, oh, I'm not going to be around that at all. So
no, not if you can help it.
No, exactly. So this year, we're celebrating how the labs came together 25 years ago to form one ERDC, one organization of experts across multiple disciplines. How do you collaborate with other researchers or organizations in the cold weather construction research?
Oh, great question. The fun thing about working at CRREL is that we are basically the cold arm of research for all of the other ERDC laboratories. So I work really closely with the Geotechnical and Structures Lab, GSL, down in Vicksburg, because they have a lot of researchers working on similar concrete problems in their airfield and pavements branch and the concrete and materials branch. And I found a lot of mentorship from concrete researchers at GSL, and I've gotten to be involved with and lead a lot of cool projects with them. One project I did, I spent about a month in New Mexico at Cannon Air Force Base, replacing concrete parking pads for V-22s. So the work I do isn't just cold-based at the ERDC, which is really fun. And then for a big concrete demonstration I did in Alaska a couple of years ago, our CRREL team was pretty small then for the concrete, group. And so we pulled in a couple of senior concrete technicians from GSL and flew them up to Alaska to work with us. And it was a huge help, and we learned a lot from them. And I think they also learned a lot about how to work in the cold. And, we had to get rid of 6 feet of snow in our whole testing area before we could even start doing any work. So I think they were having a little bit of fun being from Vicksburg and getting to come up to Alaska. And
It's fun? Is that what you really mean, fun? Really?
I mean, we were making snow angels.
Oh, good.
We were getting everything ready. So it was honestly the most snow I've ever seen in my life. So, working in New Hampshire and then these guys coming up from Vicksburg, I'm sure they were just in shock. It was so much snow.
Yes, we rarely see that white stuff here. So it's a big deal. It shuts everything down. So
it really does. Even up there, it was mind-blowing. And so I've gotten to do a lot of cool stuff with the ERDC. And then another thing we can do is we have a large testing chamber at CRREL to simulate freezing and thawing environments for concrete. And so we've been able to test some concrete from a couple of the other ERDC laboratories, specifically the Construction Engineering Research Lab, CRREL, in Champaign-Urbana, Illinois. And that's really what I like about my job is I'm able to support projects across the ERDC with my expertise and work with a lot of different research teams. And it's definitely a very collaborative environment, which I'm sure you've heard.
Oh, yes. Collaboration is key. So here we go. Can you share any cool, pun intended, by the way, real world success stories where ARCTEC made a significant difference in cold weather concrete projects?
Sure. So the main one is we're working with the USACE Pittsburgh district to be able to help them place concrete for the Upper Ohio Navigation Project, which is a mega concrete project where they're doing a lot of construction on 3 different locks and dams across the Upper Ohio River. And we've been able to help them determine how much additive they need to be able to place concrete in these colder temperatures. And we believe that we're taking months, if not, a couple of years off of their concrete schedule to be able to place concrete, in the wintertime and not have to either wait until it warms up or erect a tent and spend a little bit more money or a lot more money for, a mega project. Mm-hmm. So we're seeing a lot of success there and still kind of working with that team to define specifications. But the first time that we were able to implement ARCTEC outside of our laboratory was a few years ago with the Maine Army National Guard. And they needed to build a few concrete sling load weights, which are used to help train for helicopter operations. It's kind of like their weights that they'll carry around and hook up with the helicopter. And we were able to collaborate with them on their mix design and incorporating additives so that they could place those sling weights in February, which is, pretty cold up in Maine still.
Oh, absolutely.
And, yeah. So there was still snow on the ground, but we were able to help the guard unit place that concrete into those, weight forms that they needed and continue with their training program. So that was a pretty fun experience of kind of incorporating ARCTEC for someone who needed concrete in the winter right then.
So how long has ARCTEC been around?
About 5 years. I started at CRREL about 6.5 years ago, and my co-PI that I do a lot of the research with, Dr. Watts, he came, I think, just over 5 years ago, and we've been really using additives into the modern time. It's not a brand new technology. People were using this in other countries back in the 70s and 80s, and CRREL had a lot of research on this in the early 90s and early 2000s, and what we've done with this technology is just modernizing it and developing the tool to say, yes, you can use these additives to place concrete in the cold. They'll speed up the reaction. But how much do you need based on exactly what you're doing? And that's where Ben and I have really dialed in is how much do you actually need? Because, if you're using too much of anything, it's going to cost more money, take more time. In concrete, it could heat up too much where it's too hot, which is, kind of funny. But it's been around for a while, but ARCTEC specifically, where we've dialed in, we have a tool, we have guidance, that's been around for about 5 years.
Okay. Well, great. It's come a long way, hasn't it? So the temperature rise model sounds fascinating. Could you elaborate on how the temperature rise model simulates the effect of different conditions on concrete placement?
Yeah, the temperature rise model that we have developed for ARCTEC is very cool, pun intended. This effort has been spearheaded by my research team partner, Dr. Ben Watts, and he is an expert in thermal modeling. So we're not able to physically test every single possible scenario to know how the concrete temperature rise will look. So this model was created to be able to simulate the effects of different concrete placements at a range of additive dosages. And we get the inputs from the model from running laboratory tests. So we will do a few mixes in-house to measure our thermal and mechanical behavior at a few different temperatures and dosages. But then the model is able to expand on that data and run a lot more simulations at more temperatures, more conditions, and to provide us with just really well-rounded guidance.
So are there any limitations or scenarios where ARCTEC might not be the best fit for cold weather construction?
Ooh, good question.
Can you tell I worked hard on these?
They're good. Well, yeah, ARCTEC it's guidance for cold weather concrete, but it's also a tool. So we're able to adapt to many different project needs and capabilities. So if we're able to run a few tests in-house in the lab to better understand the materials being used, then we can provide pretty confident guidance for placements down to at least 20 degrees Fahrenheit. If temperatures are falling below 0 Fahrenheit, ARCTEC can also be used in collaboration with those heated tents to allow placements at these extreme cold temperatures. And so as we create more concrete mixers in the laboratory with different materials, different rocks, different sizes, different cement materials, we're able to add even more inputs to our model. which then allows us to develop these simulations and guidance for even more scenarios. So I would say that we do have some limitations just because, we've tested the materials we have from the regions of the country that we've worked with, but the way we can fix those limitations or kind of bridge the gap is just doing more testing in-house, collaborating with more entities who want to place concrete in the cold and just need a little bit more guidance on how to do it. Our goal with ARCTEC is that, you're able to do a lot of the testing in-house with this tool to then decide how much additive you need. We don't want to keep it, locked up at CRREL forever. We want to be able to develop this guidance and then send it out to end users so they can know, okay, it's, 25 degrees outside and I have to place this sidewalk or, this bridge curbing. How much additive do I need where I don't have to build a whole tent, babysit that for a few days, heat it up, have all those CO2 emissions. So like I said, there are some limitations now, but the more we work with other entities who are doing cold weather concreting and the more we learn about more materials, the fewer limitations there are, and we can really support across civil and military construction.
Fantastic. So what excites you the most about the future of cold weather concrete technology?
Well, first, I would say I'm excited about getting others excited about concrete, and hopefully the listeners are enjoying this concrete talk. And then with our changing world and the need to be, more environmentally conscious, there are a lot of materials out there that can be incorporated into concrete production. New materials, waste materials. And so I'm excited to see how we can handle that, especially at the ERDC, and continue making concrete more sustainable. We're already doing a lot of that across all the labs of the ERDC. How can we be more sustainable, use these materials in a better way, lower our CO2 emissions, our carbon footprint. And concrete's going to be around for a long time. So I'm excited to see how we can handle that here at the ERDC and, be more sustainable and incorporate these new materials.
Sounds great. So, we're going to close out with this very important question that I ask everyone on the show. What would you like listeners to learn about this valuable conversation?
Well, of course, that concrete is cool and it's interesting.
Yes.
And that there are just a lot of facets that go into concrete construction, especially in the cold regions. So I guess what I want to send the listeners home with is, next time you're driving around in the winter and you see a heated tent at a construction site, you need to think, that could be ARCTEC. They could be using ARCTEC, and maybe they will be in the future. I hope so.